Hello everyone, I hope you're all staying safe. Today we will be talking about the concept of a couple moment. Okay, so first let us define a couple. So, define a couple from the point of view of statics. Okay, and here is the definition. This is a very useful concept that we're going to be seeing in several problems. Okay, so two forces constitute a couple if A, they are equal in magnitude, they are opposite in direction, and they are separated by a distance, or if they are non-coincident. Okay, and they are separated by a distance, that is they are non-coincident. Okay, so two forces constitute a couple if they are equal in magnitude, okay, and if they are opposite in direction, and if they are separated by a distance. And what is the effect of a couple? It's something that we're going to be seeing. So first of all, let me draw a couple of figures, and then we will see which of these are a couple and which of them are not. Okay, so some examples, let's say. So suppose I have some kind of a rigid body, so for me a rigid body is always shaped like a potato. Okay, so on this rigid body, let's say that I have a couple of forces that are acting in the following manner. Okay, so I have a force here, and then I have a force there. Okay, so let me call this force as F. Then this is going to be the force F as well. Okay, so I'm going to draw two other figures. Now let me draw another figure here where I have another rigid body. Okay, and then I have a force acting here. Okay, and then let's say that here is another force acting as well. Okay, so this is F, and this is also F, and then I'm going to draw a third body. Okay, third rigid body, some arbitrary shape, as you can see. Okay, so here is a force acting on this rigid body, and then I'm going to say, okay, here is a force acting on the rigid body. Let's say that the magnitude of these forces are also the same. Okay, now the question is, which of them are a couple? If I look at the first rigid body, right, I see that these two forces have the same magnitude, they are opposite in direction, and they are separated by a certain distance. That is, if I extend the line of action here, I see that there is a certain distance between these two forces, right? And this is why this constitutes a couple. So this is a couple. Okay, so let me write that properly. Okay, now I go to the next figure. In the next figure, I see that, okay, that doesn't look like a couple to me, because even though the forces are equal in magnitude, they are not opposite in direction. Okay, and so this is not an example of a couple. So this is not a couple. Okay, and then the third case obviously is also not a couple, because you see that these two forces are not separated by any distance, they are not opposite in direction, and so on. Okay, so this is also not a couple. Okay, so once again, when you look at the definition of a couple, there are two forces that are equal in magnitude, opposite in direction, and separated by a certain distance. Okay, so let me just make a tick mark and say, okay, this is a couple, this is not a couple, and this is not a couple either. Okay, so what's the effect of a couple? Okay, so effect of a couple. And it is quite obvious that, as you can see from the figure where we have a couple, right? So if I look at this figure here where we do have a couple, you see that since these two forces are equal in magnitude and opposite in direction, in a sense, they will not cause the body to move anywhere. They will not cause the body to, translate anywhere. But then they have a tendency to cause the body to actually start rotating. Okay, which means that the effect of a couple is only a rotation and or a tendency to rotate the body, and this tendency to rotate the body is called as a couple moment. Okay, so the effect of a couple will not cause translation but will have a tendency to cause the body to rotate. Okay, and this rotation is called a couple moment. All right, and that's a fairly important word for us because we're going to be seeing many problems where there will be couple moments from now on. And let me try to squeeze this guy somehow to the side here so that it doesn't come across as a distraction to us. Okay, all right. So once again, I see that the effect of a couple, because this force is moving to the right, the other force is moving to the left. Obviously, they're not going to make the body move anywhere, but they will have a tendency to cause the body to rotate, and this tendency is called as a couple moment. Okay, and the idea is, okay, how do I find the magnitude of the couple moment, and how do I find the direction or the sense of the couple moment? Okay, so let's go to that next. Okay, so how to find, the next question is how to obtain the magnitude and direction of the couple moment. The direction is fairly straightforward. It will be obtained by the application of the right hand rule. The magnitude is also straightforward. You just take any one of the forces in this couple, multiply it by the perpendicular distance between the line of action of the forces, and then you're good to go. And that's about it. Okay, so let's go and say, okay, the things that we need to find are how to find the magnitude and the direction of the couple moment. Okay, so let me go ahead and do that in the next page. Okay, so let me take my good friend from here, which is a couple moment, and I'm going to draw one more. Okay, so I'm going to copy this and I'm going to bring that down here. Okay, and maybe let me draw one more where I have another arbitrary body. Okay, and let's say I have the following forces acting on this body. So let's say there is a force here that did not come out straight. Once in a while these lines never come out straight, and that immensely frustrates me. Alright, so here is a force F, and then let's say that there is this force F which is acting here. Okay, so now this is also going to be a couple, right? Because these two are equal and opposite, and they are separated by distance. Let me call this distance here as a distance d1, and then watch this. I'm going to extend the line of action of this guy here, and then I'm going to say, okay, this distance here, I'm going to call it as a distance d2, and it should be quite evident to us that this distance is the perpendicular distance here. Likewise, this is the perpendicular distance here. Okay, so this is a couple, this is also a couple. Okay, and so how to find the magnitude of the couple moment? Magnitude of couple moment, this is nothing but force times magnitude of the force multiplied by the perpendicular distance between the lines of action of the forces. Okay. Okay, between the line of action of the forces that constitute the couple. And so in this case, if I look at the first situation, then I can say that the couple moment here is going to be the force times the distance d1. Okay, and let me maybe underline that here. That's the couple moment for this case. And then if I look at the couple moment for this second case here, it's going to be the couple moment is m is f times d2. But our job is not done, right? Because we know that moment is a vector. So how to find the direction? The direction of the couple moment is given by the right hand rule of the couple moment is given by the right hand rule. Okay, and here is the right hand rule, and let me just very briefly write it out. Okay, so align fingers of your right hand. Right hand fingers along the line of action of any one of the forces that constitute the couple. Okay, then your palm must face the other member of the couple. In the couple. Then you curl your fingers. Curl of your fingers will give you the sense of the couple moment. Okay, and then the direction of the thumb will give you the direction of the couple moment. Okay, so couple of things that you see here. You align the fingers of your right hand along the line of action of any one of the forces that constitute the couple. Okay, that's the first thing. Then your palm is facing the other member of the couple. Okay, and then if you do that, the curl of your fingers will give you the sense of the couple moment, which means that it could be clockwise or counterclockwise. And then the direction of the thumb will give you the direction of the couple moment. Okay, and when we say the sense of the couple moment, we say that, okay, sense is either clockwise or counterclockwise, and by sign convention, clockwise is negative. Okay, and so CW is clockwise, CCW is counterclockwise. This we have seen earlier when we defined moments. Okay, so now if I make use of this right hand rule and I go back to my figure here, okay, if I make use of the right hand rule, the first thing I do is, okay, let me set up a coordinate system. Okay, so let's say that, okay, here is the x-axis, the y-axis, and the z-axis. Okay, so let's say this is x, y, and z. The z-axis is coming out of the page. So this is x, this is y, and then this is z. And if I use the fingers of my right hand, I will see that if I align it to the top force, which is the first member of the couple, I curl my fingers, my palm faces the other member. This is going to be directed into the page, which means that this is going to be minus f d1 in the k direction. If I then set up a coordinate frame here, same kind of a coordinate frame, the z-axis coming out of the page, I have my x-axis here, my y-axis there, and then here is my z-axis. If I take the fingers of my right hand, align it to the rightmost force, my palm faces the other force, I curl my fingers, my thumb comes out of the page, which means that if I write this as a vector, this is going to be plus k. Okay, and the basic idea is that if you're doing it on a two-dimensional problem or a planar problem, then you can as well say the following. Okay, so this is also equivalent to saying, so in a planar problem, this is equivalent to saying m is equal to minus f d1, and then this is equivalent to saying m is equal to plus f d2. Okay, that's the same thing, and I hope that makes sense to everybody. Okay, so these are the two results that we have. The negative sign says that this is clockwise. Okay, so that says this is clockwise, and then the positive sign here says that this is going to be counterclockwise. Okay, so this is the basic idea of a couple moment, and very, very quickly, let us take a look at some kind of a conceptual problem. Okay, and in this problem, I have the following situation. I have what is called as a cantilevered beam. Okay, so let me first draw it out. I'm going to draw a large box first, and then let's say that I extend the size of this box, and a cantilevered beam is something that is fixed at one end of the body. Okay, so this is an example of a cantilevered beam. Okay, this is fixed at one end. And then on this beam, let us say that I have a couple of forces that are acting. Okay, so there's a force which is acting here, which I'm going to draw in a minute. Then let's say there is one more force that is acting this way. So this is a force F1. This is also a force F1, and then I say that I have another force which is going to be F2 here, which is acting this way. Okay, and another force which is coming and hitting the cantilever at the other edge here. Okay, so let me call this as the force F2, and then this is the force F2. Okay, and then there is a distance between these two that is given to me in the problem. That did not come out straight, so let me draw it straight. Okay, so this distance is given to me as d1, and then this distance here is given to me as d2. Okay, then my aim is, okay, what is the resultant couple moment due to these forces? Okay, so find the resultant couple moment. Okay, so here is the basic idea. The resultant couple moment is nothing but the vector sum of the individual couple moments. Okay, so m resultant is equal to the vector sum of the individual couple moments. Okay, now a couple of things to note here. This is a planar problem. Planar or 2D problem. Which means that the direction of the couple moment is always going to be either into or out of the plane of the paper. Okay, so having said that, right, then I know, okay, hey, the direction is going to be into or out. All I need to care about is what is the sense. Okay, so which means that all I need to care about is what is the sense of the couple moment. That is it clockwise or is it counterclockwise? Okay. And then I can just attach a negative sign if it is clockwise. If it is counterclockwise, I call it positive and move on with my life. Okay. So here is what I'm going to do. I'm going to go back to my figure here, and you're going to do this with me very carefully. Okay. I see that the couple moment due to the force F1, okay, is going to be obviously force times distance. And let me maybe before I do that, let me take this guy and maybe scoot it up here. Okay. So that I can work with the other things. So I see that the force F1 is going to have a magnitude. The couple moment due to the force F1 is F1 times D1. Okay. And so let me write down the resultant couple moment, MR. You see, I'm not going to put the vector sign anymore because I know the direction is coming out of the page. So let me first do it using magnitudes only. Okay. So MR is going to be the following. It's going to be F1 D1. Now what is the sense? I use the right hand rule. Fingers of my right hand aligned with this last member F1, my palm facing the other one. I curl my fingers. My thumb is pointing into the board, which means that this is going to be a clockwise couple moment. And then I got to see, okay, hey, there is another guy here, F2 and F2, which also constitute a couple. And if I look at the sense of this couple moment, it's going to be F2, fingers of my right hand aligned with one of them, my palm faces the other, curl my fingers into the page. So that's also going to be minus F2 times D2. Okay, which means that the net couple moment is clockwise and is directed into the page. Okay, so this is the net couple moment, and now you see what I'm going to do with this. Okay, so this is the net couple moment. It is directed clockwise. Okay, and it is which means that it is directed into the page. Now I'm going to take all of these results. Okay, so I'm going to take this guy here along with all my forces and so on, and I'm going to show you. This is now the same figure is now equivalent to the following. Okay, so I have this guy here. So I'm now going to take this figure once again. Then I'm going to get rid of all the forces. Okay, so I'm going to get rid of all the forces here. And you know why? Because we know that these forces which constitute a couple, they do not cause any kind of a translation, which means that the only effect they cause is a rotation, which means that, hey, instead of drawing all these forces, I can just draw a nice clockwise arrow. Okay, so I can draw this nice clockwise arrow and I say, okay, this is the resultant couple moment. Okay, and in this case these two figures are now going to be the same. Okay, so these two figures are equivalent. These two figures are equivalent. Okay, and so the idea is this. Okay, what am I trying to do here? What I'm trying to do here is to say that, okay, when we are going to solve rigid body equilibrium problems, which is what we're going to be doing next, when you solve rigid body equilibrium problems, you're going to see these kinds of curly arrows. Okay, so let me write down my statement. So when we solve rigid body equilibrium problems, we will see curly arrows. Let me write my curly properly. Curly arrows in the clockwise or counterclockwise sense on the body. And what is the meaning of this? what is the meaning? Okay, it means that there was a couple moment, there was a couple, and we are seeing only the net effect of the couple on the body. Okay, which means that somebody has already done the job for you. Somebody has said, okay, hey, this is a couple, which means that what is it going to do to the body? It's not going to move it anywhere. It will have a tendency to rotate it. So I will just give you the clockwise swirl. Okay, so which means typically, let's say that this is an example of a typical figure that you will see in when we do rigid bodies. Okay, when we do rigid body equilibrium, which is actually our next concept talk or next chapter. Okay, so if I have a situation of this kind, okay, so I might see something like the following. I might see I might see maybe a curly arrow here, and then I could probably also see something on this side. I could have a force that is acting vertically down, that is some external force. I could have a force which is acting here and so on. So this could be a force F1, this could be a force F2, this could be a force moment M1, this is a moment M2. So here M1 and M2 represent the couple moments. Okay, so M1 and M2 are couple moments acting on the body. Okay, which means somebody has already done the work for you. They have reduced the effect of a couple to this couple moment, and they're saying, okay, hey, this is the couple moment, include this when you're doing rigid body equilibrium. Okay, that's essentially what it is. All right, so very brief summary of what we've done so far. Okay, this is a fairly nice concept, an important concept. It's a fairly straightforward concept as well, as you can see. Okay, so I'm just going to go back here, and we defined a couple. There are two forces that are equal in magnitude, opposite in direction, and separated by distance. Okay, that's a couple. Then, what is the effect of a couple? The effect of a couple is it does not cause any translation. It causes only rotation. Okay, it has a tendency to only rotate the body. Okay, which means that this tendency to rotate is called as a couple moment, as we have defined. How do you find the magnitude and direction? Right hand rule. Magnitude is given by force times perpendicular distance. Direction is given by the right hand rule. Okay, fingers of your right hand aligned with one of the members of the couple. Palm faces the other one. Curl your fingers. Thumb direction gives you the direction. The curl of your fingers gives you the sense. And what are you going to see from now on? You're going to see, okay, hey, if there were some couples present on this body, you are not going to be seeing these forces if they were indeed couples. Okay, you will just be seeing the direct net effect of the forces on them, which is nothing but a clockwise couple moment in this case. And case in point is a figure of this following sort, where I have F1 and F2 are some applied forces. Okay, so here some applied force. This is also some applied force. And there is this M1 and M2, which are from some other couples. Okay, this M1 and M2 are couple moments acting on a body due to some other couples. Okay, so this is due to some couples whose net effect has been simplified and drawn on the body. Okay, I hope that makes sense. The drawn looks like a drown, so I don't want to do that. So drawn on the body. Okay, so I hope this makes sense. I hope all of you are also staying safe. Take care of yourselves, and I'll see you in the next concept talk. Bye bye.